This is the return of procedural programming. I'm Richard Feldman. So back in the 1990s, my hometown, I used to go to Borders Books and Music a lot. Anyone ever been to a Borders? Not really a thing. Okay, a ton of people. Wow. I would walk around, and this is sort of before the internet. Like, we didn't have the internet at my house. Nobody I knew had the internet. My dad had like the internet at work at the university a little bit, but it was mostly for email. So the main way that I learned about new programming things was from books. And I remember walking around this Borders, and I would see all these books about this hot new, super hyped thing, object-oriented programming. See books like this. Head-first object-oriented analysis and design. Sometimes you'd see exciting new releases of object-oriented languages like Java 1.1. You would sometimes see object-oriented programming books at different demographics. There was just this overwhelming tidal wave of hype and excitement around object-oriented programming. It was so clear that this was the future, that the old sort of procedural programming way was a thing of the past, and the thing of the future was OO. So I remember like walking around Borders and thinking this, and this kind of stuck in my mind. I got into industry, I became a professional programmer, did a lot of object-oriented programming. So imagine my surprise, and imagine my sort of telling my past self about ETE a couple years ago, 2019. Here's Andrew Kelly talking about the Zig programming language, which he created. It's one of several new up-and-coming low-level programming languages. And he's talking about, hey, we're trying to make a better C. We're not trying to be like C++. We're actually intentionally making this new programming language not object-oriented. And Zig's not the only one. You also see like Rust, not an object-oriented language. Very, very popular, getting a lot more popular. Odin, JAI, these are two other low-level systems-level programming languages. Really, of the last like 10, 15 years, the only like low-level language in that group that I hear being talked about that is object-oriented is Carbon, which is a language that's explicitly designed to be a C++ successor and have C++ interops, so they kind of couldn't get away from it. This is a really far cry from what I remember of like OO being like the obvious future, the thing that everybody was going to be doing. So we're talking about here procedural programming, sort of the thing that came before OO, and in this talk I'm going to be talking about to what extent is it coming back. So procedural programming is not object-oriented. It's also not functional. So procedural is an imperative paradigm. It's not really concerned with mutation or side effects or the lack thereof. And it's also not new. It is the thing that we had before object-oriented programming, and it's sort of starting to see a resurgence. So partly it's in these new languages, but also it's just in existing mainstream procedural languages getting used more. So Stack Overflow has been running this survey for the past 6+ years about which programming scripting markup languages have you personally used in the last 12 months. And we can see some interesting trends in here. Here's sort of the raw data, but just some highlights. So among object-oriented languages in this survey, people saying, I've used this in the past 12 months. TypeScript and Kotlin, huge increase, massive increases in TypeScript. This is probably not news to anyone in here. If you're in the Android development world especially, you probably have heard about Kotlin just being this absolutely huge thing there. Python and C++ both saw a 50% increase over the past 6 years, which is a big deal because they were already super high in terms of usage. I'm assuming that AI has a big part of this, so both Python and C++ seeing a lot of use in AI. There's a lot more work being done in AI these days. Also Python seeing a lot more work in data science. That's been sort of an upward trend. And C++ also in games, and more games have been getting developed compared to like the 1990s, for example. C#, Java, JavaScript, kind of no change, but they're already sort of on top, so it's like moving up is really noteworthy when you have that much usage already. Then they also saw some decreases like Swift and Objective-C, 30 to 50% decrease there in terms of like how many people said they'd use them in the past 12 months. PHP, Ruby, Scala, I can think of various explanations for these things. Like Swift and Objective-C, just maybe a smaller percentage of people are doing iOS development. That's pretty much where Swift and Objective-C are being used. Also, a lot of Objective-C is being moved to Swift intentionally. PHP and Ruby, like Rails is less popular. Ruby's popularity in terms of like worldwide usage has been pretty coupled with Rails's. So if fewer people are doing Rails, fewer people are doing Ruby. PHP has become more of a niche thing that's kind of used for like WordPress and Drupal and not nearly as much like general websites as it used to be. And Scala, I think its decrease would be explained in large part by the increase in Kotlin, because one of the 3 different ways that people use Scala is sort of as like Java++, or I've heard the joke being Java without semicolons, and Kotlin also offers some of that same sort of Java, but sort of taken in a slightly different and maybe arguably improved direction. Okay, what about procedural languages? Because there are also certainly some long-standing mainstream procedural languages. What do their trends look like? Well, C's seen like a 30% increase over the past 6 years. So part of that could be explained by C++. I bet there's some double counting there where a lot of people who are saying, I'm doing C++ are also answering, yes, I've done C in the last 12 months. Go, 100% increase. I don't have a double counting explanation there. It's just like, seems like a lot of people seem to be liking Go. Anecdotally, this conference, I've had 3 different conversations with random people in the last couple days, and 2 out of the 3 said they are adopting Go at work. And I think that's just because people like Go. And maybe it's because they got generics now, I don't know. But one way or another, Go seems to be increasing in popularity, and it's just not an object-oriented language. It's procedural programming. And then, of course, Rust. I gave Rust 1,000% increase, but that's actually being generous because 6 years ago, Rust wasn't even on the chart. Like, it was kind of 0. So you could say that's an infinity percent increase, but that doesn't seem reasonable. So to be generous to the other languages, we'll just cap it at 1,000%. But point being, Rust went from essentially not being on the chart 6 years ago to now it's like 10% of respondents said that they used Rust in the past 12 months. So absolutely massive increase. No classes, no objects in any of these languages, no subclasses, no inheritance, just procedural programming. And so since we saw sort of a mix of up and down on the OO side, and all of the mainstream procedural languages, or at least all the ones on this survey, have seen some form of increase, putting those 2 together, that means that in the last 6 years, at least among Stack Overflow survey respondents, object-oriented programming lost ground to procedural. Like, some of them went down, none of the procedural ones went down, they all went up. What's going on here? I thought OO was supposed to be the future forever. So this is what we want to talk about today. Is why is it that procedural programming is becoming proportionally more popular? Now, to be clear, OO still rules the roost. It's still the most popular paradigm on the planet, for sure, by a healthy margin. The question is about the trend. Why is it becoming more popular? Why is it sort of coming back, even though it's the thing that came before OO? So, outline of the talk. The first and largest section is going to be talking about differences in features between the procedural paradigms and OO paradigms. I'm going to break it down into sort of 2 different categories of OO. A little bit shorter section, differences in style between the 2, and then the shortest section of all is going to be at the end. So sort of what changed? What is it that sort of putting all these things together changed to make procedural programming start to come back? So we'll start with differences in features, and just to sort of set the scope of what we're talking about, for this talk I'm just going to focus on the paradigms of procedural and mostly object-oriented, and just kind of briefly mention functional. This is mostly talk about imperative programming, so I've talked a lot about functional programming in the past, but this talk is not about that. So also not going to get into other paradigms like logic programming. It's really just kind of going to be procedural and object-oriented and their differences. Okay. So thinking about sort of like what's the essence of the paradigm. So a language paradigm is in a lot of cases about some combination of language features and also the style in which you use it. We're going to start off by talking about the features. So the procedural sort of like feature set and style, I guess, is the introduction of the idea of using procedures over go-tos. So if you look at the hardware, like the hardware doesn't have a concept of procedures. This is a new paradigm that we sort of invented on top of the hardware, and having this sort of abstraction of the idea of a procedure built in terms of essentially go-tos like conditional jumps and non-conditional jumps. And this like concept of the stack and things like that. So it's basically just the idea of, hey, what if we organize our programs into procedures? This is becoming a rather popular idea. Basically all programming does this now. You could be forgiven for thinking, what do you mean paradigm? That's just programming. Because this is a paradigm that has really, really stuck around. Functional would be sort of like procedural with restrictions, I guess you could say. It's sort of like, let's take procedural and then also try to avoid mutation and side effects. Object-oriented, a little bit trickier to define, so let's sort of talk about that. So another past ETE speaker, Alan Kay, gave a keynote. Alan Kay is the person who coined the term object-oriented. And he coined this term at the University of Utah, and so at first in 1966, he sort of described what his influences were when he was doing object-oriented programming, as he later called it. He talked about Simula, so we'll talk about Simula a little bit later. So Simula was the first language that introduced the concept of objects and classes. It started off as a DSL for describing simulations. That was like its purpose as a language. And then in the second edition of Simula, they decided, you know what, we think this is actually a good idea, and people should try to use this style of programming for things other than simulations. And that was when they introduced the terminology of objects and classes in that second edition of Simula. Whereas before they'd use like, I forget, it was like systems and procedures or something like that, or processes. So Alan Kay was inspired by that. He also was inspired by the design for the ARPANET, or the internet as we now know it. We'll definitely see that. He really thought about objects as essentially kind of like little tiny servers. And finally, my background in biology and mathematics, which had to do with like metaphors for how cells communicate, and mathematics in terms of like algebras of how things are organized. And he used this term, he said, I thought of an architecture for programming. We're going to contrast this with other sort of schools of OO that don't really think about it as much of as an architecture as he did. Probably in 1967, when someone asked me what I was doing, and I said, it's object-oriented programming, and it stuck. That's what people use to describe this, this style of programming and other styles that he doesn't think count. Okay. So later in 2003, Alan Kay said, sort of by means of clarification, to me, object-oriented programming means only the following. Messaging, we'll talk about what that means. Local retention and protection and hiding of state process. I think he means encapsulation by this. I don't know what else he could mean by this, but let's assume he means encapsulation. And extreme late binding of all things. We'll also talk about that. He says it can be done in Smalltalk and in Lisp. I gotta admit, I heard that and it kind of threw me for a loop because I don't really think of Lisp as an object-oriented language in the sense that like it's what a lot of people call the first functional language, and also Lisp explicitly added, like there's like the common Lisp object system, like that was like a separate thing later, and if it was already object-oriented, why would you need to add an object system later? Also, they don't use the term objects or classes or anything like that in Lisp. I don't know, but apparently to Alan Kay, this is an example of a language, like one of the two languages that can do it. And then he goes on to say something that was even more confusing to me, which is, there are possibly other systems in which this is possible, but I'm not aware of them. Now, he said this in 2003, at which point Objective-C and Ruby had been around for like multiple decades. So I'm not really sure, I guess Ruby less than 1 decade, it was 1995, but they've been around for a long time, and both of these languages do messaging, encapsulation, and extreme late binding. So I'm not really sure what he was talking about there. Regardless, let's talk about what messaging means, because this is maybe not something that you might think of in terms of object-oriented programming. It's certainly not something I thought of back in the 90s. So messaging is essentially, in the object-oriented context, what Alan Kay is talking about is the idea that calling a method on an object means sending a message to that object. Like you've got some piece of information, you're sending it to the object receives it and then decides what to do with it. So really, the object sort of decides when, like in real time, at runtime, when it gets this message, what am I going to do just based on looking at the message and looking at like my state, the state of the world, all those types of different things. Essentially, just like what an HTTP server does. If you've got a web server and it receives a request, it can decide on the fly what to do with that, including nothing. It can say not found, and it can change its answer about not found all the time, at runtime, at real time. This is exactly Alan Kay's concept of what objects were. And in fact, he's talked at length in different contexts about how he sort of saw each object as sort of like a tiny computer or like a tiny server. And the idea of object-oriented programming to him was this recursive design idea where everything was like computers all the way down. Ruby explicitly includes this idea of messaging. So if you look up the official Ruby documentation about what calling methods is, it says, calling a method sends a message to an object so it can perform some work. And it's got like an example of the syntax, myObject.myMethod. It says, this sends the myMethod message to my object. And if you included arguments in that, those would also be part of the message that gets sent to the object. So Yukihiro Matsumoto, aka Mats, was very directly influenced by Smalltalk when he developed Ruby, and he wanted to include this idea of messaging in it. Okay, so he also mentioned late binding, extreme late binding in all things. If you're not familiar with that idea, this is essentially the idea that like the list of methods an object supports and what they can do can change in any way at runtime. And this is kind of an extension or like an implication of the messaging idea. Essentially, like you're getting a message in and you can decide, hey, like right there on the fly, do I support this method? Do I have it? What arguments does it accept? What are their types? You can decide that as late as you want. You can change them on the fly. You can say, every 30 seconds, I completely scramble what methods I support, and I delete half of them, and then I add new ones. You can do that, all that. This is a really critical thing to Alan Kay. Like, this is an important part to him. If you're not doing that, if you don't support that, and do like extreme late binding in all things, it's not object-oriented programming. So in other words, when you see some syntax like this, that's what it's supposed to be doing. You should have no idea at compile time what that is possibly going to do, if it's going to do anything, if it's supported, any of that stuff. Now, an interesting implication of this is that this is completely at odds with static type checking. Static type checking is where you say at compile time, not at runtime, I've got an exact list of all the methods that are supported. I will check them. I will give you a red squiggle in your editor if any of them are not supported at compile time. And they shouldn't change at runtime if you want to be able to type check them. If you do want to change them at runtime, fine, but now we're outside the world of static type checking. Now, I mention this because there's been a pretty strong trend of increase in the use of static type checking, which is really at odds with this idea of extreme late binding of all things. So we have Smalltalk, which is influenced by a descendant from Simula. We have Objective-C in 1985, so Simula 1960s or late 50s. Smalltalk 1972, yeah, 1972 because it was the same year C came out. And then Objective-C 1985, Brad Cox creates this language, and it's basically like he starts with C and he wanted to add some productivity features to it. He just read about Simula in Byte magazine, Smalltalk in Byte magazine, and he says, you know what, I'm going to try and add some Smalltalk features to C, and he ended up calling that Objective-C. He included the message passing idea, the late binding idea, all that good stuff. So if you look at actually like even modern Objective-C documentations, this is from Apple, because the way Objective-C ended up being used in practice essentially was exclusively as kind of an Apple thing. But like they have this method, you know, message sends a message with a simple return value to an instance of a class, aka an object. So this idea of messaging persists today. Although, again, for some reason Alan Kay doesn't think Objective-C counts as OOP, but Lisp does. Anyway, now Python, despite being a language that a lot of people would consider object-oriented, didn't do those things. It was not, like Guido van Rossum was not influenced, at least not like really influenced strongly by Smalltalk, but rather he had personally used Simula and had a good experience with it, and he wanted to incorporate Simula into this language, or Simula ideas, namely like classes and objects, into this language he was creating called Python. So he did. But he didn't include the messaging idea. That was like kind of the Alan Kay Smalltalk thing. And this is like one of the first examples we'll see of object-oriented languages, or languages we think of as object-oriented, that didn't fit Alan Kay's definition at all. They didn't do messaging. Certainly it did the late binding thing, but not messaging at all. Ruby was actually, so again, Yukihiro Matsumoto, aka Mats, created Ruby, and he was aware of Python at the time, and he specifically wanted in the design of Ruby to make a scripting language that was more object-oriented than Python. And what he meant by that is essentially more like Smalltalk. Like it actually included the idea of messaging, like we saw. There's another language that, how many people have heard of Self? One, two, okay, so not a lot. So Self, don't worry, you'll recognize the language that, that ends up being descended from Self. So Self was this programming language that descended from Smalltalk. The authors wrote this paper about it. Self, the power of simplicity. Unlike Smalltalk, Self includes neither classes nor variables, variables meaning like members. Instead, Self has adopted a prototype metaphor for object creation. How many people have heard of prototypal inheritance? Okay, a lot more, a lot more. How many people have heard of the most popular prototypal inheritance language, JavaScript? Hey, all right, cool. So this is kind of Self's legacy, is that it inspired JavaScript's original inheritance system. I'm using JavaScript's original like 1995 logo for reasons that'll become apparent later. You might know JavaScript by its more modern logo, which looks like this. Yeah, so the whole late binding thing, not static type checking, yeah, there's that trend. So basically, Self was sort of an inspiration for JavaScript, but even before we got TypeScript and sort of the move away from extreme late binding in all things and towards static type checking, we did see some other trends around like Self's idea of prototypal inheritance, namely that like ES6 JavaScript introduces classes, and that sort of becomes the sort of preferred official way to do inheritance and OOP in JavaScript over the prototypal inheritance idea. Still supported, but it's really like when you read tutorials and stuff, a lot of times people talk about kind of the new shiny ES6 classes way. And the reason they added that is just pretty much the rest of the world except for JavaScript is doing class-based inheritance. And it seems like the prototypal inheritance idea, maybe it was cool at the time, but it doesn't really seem to have stuck around. It seems like it's kind of going to end with JavaScript. You can look at Dart as another example of this. So Dart is a language that's like very, very directly an offshoot of JavaScript, but they didn't even bother to include the prototypal inheritance thing. They just used class-based inheritance. So this is one of several ideas that we're going to see in this talk of sort of branches of OOP that, you know, they got tried out, they were mainstream, they had their time in the sun, and now people are just moving away from them. And for one reason or another, there could be a lot of different factors to do with that, but the idea just doesn't kind of seem to have stuck as much as some of these others have. Also, we've seen kind of a move away from messaging. So we saw that like Ruby and Objective-C explicitly included messaging in their designs. Well, Objective-C's successor language, Swift, which was developed at Apple with the express purpose of being like, let's do this for iOS development and Cocoa and all that, instead of Objective-C, sort of the modern alternative, doesn't even include messaging except specifically as a way to do backwards compatibility with old Objective-C code. Similarly, Ruby, you've got sort of an offshoot of Ruby called Crystal, which is, you could draw some parallels to Dart, but not perfect parallels. But it's basically like a very, very Ruby language that explicitly uses static type checking and static dispatch. So it sort of really walks away from the idea of extreme late binding of all things. Also, we noted that back in the Stack Overflow survey that Ruby and Objective-C were two of the languages that had the most decrease of all the object-oriented languages in that list over the past 6 years in usage. So again, I think that's mostly because of Rails and because of Swift, not necessarily because of any problems in the Ruby language or Objective-C. But it is worth noting that, again, the industry seems to be moving away from this idea of messaging. And also, like I said, moving away from the idea of late binding, all of these languages down here, Python, Ruby, Crystal, Swift, TypeScript, either they have type checking baked in, or in the case of like Python and Ruby, they've now added official language extensions so that you can add type checking. So it's really not looking good for Alan Kay's sort of vision of what he considers to be OOP. So, he said this only, OOP to me means only messaging. Again, encapsulation, definitely still here, definitely still a thing. But as far as messaging and extreme late binding of all things, really doesn't seem like that's kind of like the future. In fact, I don't want to say that it's dead, but it seems to be well past its peak at this point in terms of popularity. Okay, so we've seen some differences in features here. So the Alan Kay style of object-oriented programming, messaging and late binding. Procedural programming, in contrast, is kind of just, I don't know, don't do that. Like, it's not really like procedural. It's like, here's what we do instead of that. It's just sort of like, I don't know, we just don't do messaging and late binding, right? That was sort of what came before. And so when I say that procedural programming is rising in popularity, it's not so much that people are like, oh, here's this shiny new way of doing things. It's more just like, actually, maybe we'll just not do that and go back to the old way before we did those things. I guess if you could call it a feature and sort of like express it in a more positive way, it would be like procedural is more about just like plain old functions and plain old data being passed around between them. Okay, now of course there's another whole branch of OOP, which is probably what most people, myself included, think of more in terms of OOP, which this is not the person who coined the term. This is Bjarne Stroustrup. Does anyone know what he's most famous for? Okay, yes, that is of course the language that I'm about to talk about next. So Bjarne Stroustrup he had used Simula in the past, and then he had also used C, and he decided to put them together in a language that he called C with classes, which I assume was what everyone was thinking of. Anyone heard of C with classes? I see a couple of hands. Has anyone heard of C with classes and they didn't hear about it from me? Okay, one, cool, 1.5. Right, so I didn't have a logo for C with classes because it was kind of a short-lived language, but I made one up, C with classes. But basically, like C with classes essentially was kind of what the name says. It's like he took the C programming language and he just added classes to it. He also, as a bonus, added static type checking, or like stronger static type checking to it. So already he's like the polar opposite of Alan Kay's vision for OOP. But essentially what he found, this is like kind of an interesting case study, was with C with classes, he described it as a medium success, meaning that like, yeah, it worked, it like did the thing. I added objects and classes to C. The problem was that it was like kind of just a bunch of his friends using it, and it wasn't really gaining widespread adoption. And he considered this a problem because he didn't really want to keep maintaining it if it was just going to be this kind of like little medium success. And so what he ended up doing was he decided, well, I don't want to shut it down because that's just going to like hurt all my friends, and I also want to keep maintaining it on my own. I bet if I add a bunch of other features on top of the object-oriented stuff, maybe more people will find it useful, and then they can help me maintain it. So he did, and then he decided to rename it from C with classes to C++. How many people here have heard of C++? Hey, it's like JavaScript again. Cool. All right. So yes, this became slightly more popular. Now, what's interesting about this is that it's a little subtle distinction, but it's worth noting that if you just took C, which is already a very popular language, and you added just classes to it, the OOP stuff, that wasn't enough for it to be popular. He had to add all this other non-OOP stuff before it got popular, which kind of tells us something about, was it the OOP part that caused C++ to get popular? Well, obviously not, because when he added that, it was C with classes, which nobody heard of. the thing that caused C++ to get popular was that other stuff that he added on top of it, because before that, when it just had the OOP stuff, it wasn't popular. And yet, I remember the 90s thinking, oh yeah, OOP is big, just look at C++. And these kind of got conflated, like that was the causal relationship there, but we did the experiment, and the experiment was like, actually, if you just add OOP to C, it doesn't get popular, and it's like the same guy even. So, at any rate, C++, quite a popular language. Alan Kay, not a fan. In 1997, he said, I made up the term object-oriented, and I can tell you that I did not have C++ in mind. Fair enough, be that as it may, I mean, as we've seen, it seems like this is sort of the family of OO that ended up taking over, whether or not the originator of the term is happy about that. That's how it ended up happening. So one of the most famous languages that sort of is descended from C++, and in fact was explicitly designed to appeal to C++ programmers, is Java. I've carefully organized this slide so that you can see the Java logo next to another logo, which, remember JavaScript from 1995? A little bit of a backstory there. JavaScript was originally supposed to be Scheme, like a functional programming language dialect, functional programming Lisp, no less. That was what Brendan Eich was planning on developing at Mozilla for their use in the browser, the Netscape browser. And essentially, Java comes out. There's this huge, like, literally multiple hundreds of millions of dollars of marketing from Sun Microsystems just for Java, the programming language. So the hype was real. Mozilla says, do you see this hype machine that's coming? Put Java in the name and like make the logo be Java, make the syntax look like Java, just Java-ify what you're doing. And Brendan Eich's like, all right, I guess. So yeah, it sort of became JavaScript. It was originally called LiveScript, and the rest is history. PHP, another offshoot of C++, like Rasmus Lerdorf, also Danish, was sort of doing C++ programming and doing web programming, and felt that it was like kind of too clunky to try to do web programming in C++, and ended up inventing PHP. Later on, C# ended up being sort of Microsoft's kind of like version of Java that had some differences and things like that. But this whole family of languages really comes from sort of Bjarne Stroustrup's version of C++, where he just wasn't interested in messaging. He wasn't interested in extreme late binding of all things. In fact, he was quite into static type checking. And as we've seen with kind of the trends of these things, this sort of seems to be the version of OOP that ends up being most widely used in industry. He gave a talk called The Design of C++, where he sort of talked about like his motivations and stuff. It's like from like the 1980s or something. And he highlights some of his goals with this was with C with classes originally, but those goals, persisted through C++. He talks about like program organization was the first thing. He was sort of like, Dennis Ritchie did a good job creating C. It had a lot of stuff, but it doesn't really tell you how to organize your programs. He also talked about wanting to maintain C's runtime efficiency, availability and portability, interoperability. Like he didn't want to sacrifice those things. But program organization was the thing that he said he was concerned with. That's like what he was really all about. And when I talk to people about things that they like about OOP, this is one of the things that really commonly comes up. So Alan Kay was like, I had this vision for like an architecture of programming. Stroustrup more about program organization. And the thing that he ended up sort of popularizing, and that I hear a lot of people say they like about OOP, is the idea of combining actions on data types. Like you organize them in the same place. You've got your class, and then it's got a bunch of pieces of information, and then you've got methods on that class. It's a really natural way to sort of like couple these two things together. And in fact, even in modern programming languages that are not object-oriented, like functional languages, procedural languages, they tend to use modules for encapsulation rather than classes. But you really commonly see this same sort of organizational strategy. So Evan Czaplicki, who made the Elm programming language, he used to have this saying that I really liked and found useful in Elm, which was talking about, he said, like, usually a good module is built around a particular data type. Like you'll have one type, and that usually will be the same name. The name of the type is like the same name as the module, and the module will expose that type, and then you have a bunch of functions in that module that work on that data type. Crucially, this is more of a convention in the modules world. Like in the classes world, it's like very strong. It's a very strong default. It's a very strong cultural thing. If you just got modules and not classes, you can still do it that way, but it's not as strongly encouraged as it was in C++ and in all the object-oriented languages that followed it. Very strong organizational culture around classes. Another thing that I've heard a lot of is the pillars of OOP. So this is something that comes up a lot in OOP teaching. It's interesting, there seems to be a bit of a disconnect, because when I look at early beginner object-oriented tutorials and stuff, this is super commonly talked about. When I talk to people in industry, they're like, oh yeah, the pillars. I think I've heard of that. Does anyone here know what the pillars are offhand? Yeah, right. Like it's not. You can't just like rattle them off. So here's what you see. If you look up like what are the pillars or the principles of OOP, you always see these four, or sometimes only three, but abstraction, encapsulation, polymorphism, and inheritance. Let's kind of like go through these a little bit. And by the way, these are like kind of a state of values, not unique benefits, as we will see in a second. These are sort of things, I wasn't quite sure what the word pillars meant, but my conclusion after talking to various different people about this is essentially that these are not claiming that these are uniquely OO benefits, because they're really not, but rather that like these are sort of values. Like if you're doing OOP, these are things that you should value. So abstraction, kind of the idea of like, the general idea of like, don't depend on implementation details, just depend on sort of an abstraction of an idea of something, rather than the specific, like here are the actual shape of these bits and bytes in memory. Encapsulation is sort of preventing depending on implementation details. So you have like a public-private split, and you're not allowed to depend on the private details. You're only allowed to depend on what's publicly exposed. Polymorphism is essentially, again, about implementation. It's where the implementation of something abstract is determined by its type. Practically every modern language has these. They might call them different things, but like, abstraction, what language doesn't have that? Encapsulation, sometimes you might hear that called modularity, but again, what language doesn't have modules with like public and private stuff? Some things are exposed, some things aren't. Polymorphism, again, basically every language has that. Go just got generics, aka parametric polymorphism. Go doesn't have classes, but you don't need classes to have polymorphism. Which kind of leaves us with inheritance, which is, I would say, something that is pretty uniquely OO. Like you don't find inheritance in like functional languages, or not necessarily, unless they're like sort of hybrid OOFP. You don't necessarily find it in procedural languages, especially not implementation inheritance, which, to be fair, there's interface inheritance, there's implementation inheritance, but really the one that's sort of OOP-centric that you really only find in OOP is implementation inheritance. So when I'm talking about inheritance here, I'm talking about implementation inheritance. Implementation inheritance is essentially hierarchical code sharing. I would contrast that with composition, which is sort of non-hierarchical code sharing. And of course, we've all heard that the recommendation in the OOP world is to prefer composition over inheritance, which is the thing that basically every language can do. Let's get a little bit more specific about what that means so we can kind of see why people might prefer that. So why prefer composition over implementation inheritance? So shout out to Martin Snyder. He gave me this really concise example of, of why people come up with this rule. Let's say you have a class and it's got 3 methods and they sort of call each other. And I'm making a subclass of that and I override one of those 3 methods. The other 2 are still calling that method that I overrode. And the problem is that if I didn't realize that those other 2 methods were calling the one that I overrode, I might have just broken them, like accidentally. I didn't even know they were doing that, like, because I don't really have an innate way to see that they were doing that. That's not really part of the semantics of the language. It's just a thing that can happen. This is potentially a source of bugs. It's like I end up, causing a bug in my program because I accidentally overrode the behavior of a superclass completely unintentionally. This is a downside of implementation inheritance. Now, in contrast, the composition approach is basically we're saying, okay, well, instead of using subclassing to override the method to add new functionality, why is it that I'm subclassing? Well, it's because I want all the behavior of the parent. I want access to all that behavior, but I want to do some other things that are different. What I can do instead of that is I can essentially, well, okay, I'll just make a new class which has the original thing as a member of that class. So now I can still access all of its functionality, but I'm not changing any of it. I'm not overriding anything in it. All of its methods are still there, still intact. There's no chance of me causing that bug that I just described if I do it in that style. But of course, once you're doing this, it's like, well, that's just nested structs in C. Every programming language could do that, functional, procedural, etc. So at this point, we're not really talking about like sort of a strength of OOP. Arguably, you could say that the fact that implementation inheritance is a downside of OOP. The fact that it's like the foot gun is there when it's recommended to do this other less error-prone thing instead. Okay, so going back to the idea of like the essence of the paradigm, procedural, use procedures over go-tos, functional, it's like procedural, but with the added caveat of avoiding mutation side effects. And then we're going to break down OOP into 2 categories for Alan Kay. This is messaging and extreme late binding of all things. And for Bjarne Stroustrup, it's hierarchical code sharing through implementation inheritance, which is kind of disfavored in favor of composition. Okay, so there ends the longest section of the talk, the differences in features. Now let's talk about the differences in style between object-oriented and procedural programming. So it's pretty hard to find like someone actually saying, here is how to do the procedural programming style. Not quite the same level of hype as the object-oriented style. Even this many years later, the best thing I've been able to find is this YouTube video that has 2 million views, which is, not an entire bookshelf worth at Borders, but, it's a lot of views for a programming talk. So in this talk, he definitely talks about, like, we're talking procedural and imperative, so this is not a talk about, like, functional programming style, but he does talk about sort of what he sees as the essence of the procedural style, which is something that does have things in common with the functional style, namely that he says, look, this is about let data just be data and let actions just be actions. That's the essence of the procedural style. So not doing this hierarchical organization of classes and subclasses, just data and procedures that operate on that data. That's kind of it. And put them in modules if you want to have encapsulation. So he goes through 4 different examples in that talk of essentially taking object-oriented code and then, without changing the language, rewriting it into what he sees as like the procedural style version of that. So one of these that he took an example from Sandy Metz, one of her talks. So Sandy Metz, awesome human being, just lovely, delightful person, also complete authority when it comes to object-oriented style, like absolutely legend in the community. So this is code that I think is definitely fair to say is like representative of good object-oriented code. So in that talk, she sort of refactors some code that has some problems and ends up with this. This has 3 classes, FTP downloader, patent job, and config, and 9 total methods. And the refactored version has no classes, 5 total procedures, and they're all named after verbs. I mentioned the verbs thing because there's this blog post by Steve Yegge called Execution in the Kingdom of Nouns that the author of that talk referenced in that talk. And this is a talk mostly about, this is a blog post mostly about Java. Steve writes, classes are really the only modeling tool Java provides you. So whenever a new idea occurs to you, you have to sculpt it or wrap it or smash at it until it becomes a thing, even if it began life as an action, a process, or any other non-thing concept. So in other words, you might look back at this and say like, okay, why do we need a thing called FTP downloader? Couldn't we just write a procedure that says download over FTP? That type of thing. Why do we need a patent job? Why don't we just have a function that says, process the patent? He goes on to say, I've really come around to what Perl folks were telling me 8 or 9 years ago. Dude, not everything is an object. Fair enough. That's there's definitely something to that idea. Even though I distinctly remember back in the 90s, the first time I heard about Java, and I had been doing C++ before that, I was thinking like, oh, everything's an object. That's really nice and consistent. I like that. But much later, I kind of came to appreciate this perspective too, where it's like, okay, maybe I would like to have, you know, the less of the what I have is a hammer and everything starts to look like a nail. So this idea of like nouns and verbs, like you see in the object-oriented version, you have a class called FTP downloader. In the procedural rewrite, he just says, yeah, we're not going to have FTP downloader, we're just going to have FTP download file. That's just a procedure that downloads the file over FTP. Instead of a patent job class, he just says we're going to have two procedures, process patent and parse patent, and then config. Okay, fair enough, that makes sense because that is just a piece of data. He didn't make a separate class for that because, you know, in Ruby you don't have to, but point being that this is sort of much more verb-oriented than noun-oriented because he decided that was just the better fit for what they were doing in this case. Now this idea of hierarchical classification of like classes and subclasses and, you know, implementations, inheritance is not unique to OOP for sure. I mean, hierarchical classification you find all over the place, for example, in math. So this is like the numeric hierarchy in Lisp, which, okay, maybe according to Alan Kay that's object-oriented, but I think most people would say that's either functional or procedural. There just is a hierarchy here. You look at Haskell, you can see, again, a further mathematical hierarchy of monads and applicatives and foldables and functors and stuff like that. Again, like hierarchies definitely appear in programming languages. It's not like hierarchy is only an OOP thing. But you do see a lot more hierarchy in OOP than you do in procedural or functional. How many people have gone through an object-oriented programming tutorial where you saw something like this, like dog inherits from animal, you know, car inherits from vehicle, you know, bicycle does too. Yeah, okay. So this is a really common thing. You don't really see this in tutorials for procedural programming or functional programming. This idea of hierarchy is really kind of essential to, especially the Bjarne Stroustrup school of C++-based OOP, that just kind of isn't there for procedural or functional styles. This is the sort of class hierarchy inside Ruby for all sorts of different things in the standard library. And you can see that, like, for example, just within errors, we have like float domain error, which is a subclass of range error, which is a subclass of standard error, which is a subclass of exception, which is a subclass of object. Now, that is one way you can organize errors. You can certainly say, like, this is a that, is a that, is a that, but it's not the only way to do it. Again, in Java, we see here's like the standard library. This is a mix of interface inheritance and implementation inheritance. If I just kind of zoom in on tree set at the bottom here, this has an equivalent in Rust. So in Rust, this would be a B tree set in the standard collections package. Tree set inherits in Java from sorted set, which inherits from set, which inherits from collection, inherits from iterable. Whereas in Rust, you have these things called traits, and there's just a flat list of them. So you still do have a bunch of different things that you can do with a B tree set. It's just that there isn't this hierarchical description. It's just that's just not the focus in Rust, because Rust isn't object-oriented. All of these things that I just talked about are examples of abstract types. This is a particular type of abstraction. So interface, for example, in Java, this is an example of abstract types. So I'm saying, hey, a shape, I'm not telling you anything about how the shape is in memory. All I'm telling you is if you give me a shape, whatever that means, it has some method on it called area. I can ask it what its area is. It's going to give me back an integer. See the same thing in Go, even though Go is not object-oriented. It says, you can have an interface about shape. It's just like, yeah, all I know about this thing is if I ask it for its area, it gives me back an integer. Same thing in Rust, except now it's called a trait instead of interface, but same basic idea. I got this thing called a shape. If I ask it its area, it gives me back an integer. And in Haskell as well, with type classes. You know, it's different syntax, different name for the thing. All of these are just examples of abstract types rather than concrete types. So concrete type might be, for example, like a rectangle that's, you know, got a particular implementation of area that's specific to rectangles, or a triangle that has got a particular implementation of area that's specific to how it works in triangles. So again, it's this fundamental idea of if I have a shape, all I know about is I can ask for its area and get back an integer. Now these are all in statically type-checked languages. I can't quite say as much if I've got a dynamically typed language like Python. So in Python, again, this looks a little bit different. So I'd say class shape and then def area. And then the convention, as far as I've been told, I'm not actually a professional Python programmer and have, most Python I've done is helping other people with their Python homework. But apparently this is the style, is that you define the class and then you say, you raise a not implemented error by default. And the idea is that if you want to make a concrete class, like rectangle, then you would say, okay, I'm going to define the area to actually do something, like the actual implementation of the area of a rectangle, which is the width times the height. Okay, you can do something similar in JavaScript, but you can do it with prototypal inheritance like we talked about. So I'm, again, using the 1995 JavaScript logo. So prototypal inheritance version looks like this. You got function shape. I don't know why they use function for that, but that's how it works. Shape.prototype.area equals, and then you define essentially the implementation to initially just throw an exception, and then you can override that for a particular like rectangle prototype where you implement it as width times height, just like before, and then you can say answer equals rect.area. Now, another thing you can do in JavaScript is you can do this in a completely not object-oriented style if you want, and get exactly the same sort of data abstraction at the end of the day. So here's how that might look. You might say rect equals, and this is just like an anonymous object. I'm not defining any classes, I'm not doing any prototypal stuff here. Area is a field on the record, or the object, that is an anonymous function that just says return rect.width times rect.height. So what is rect here? Well, this is just from the outer scope. This is just an example of a closure that's capturing something outside of its scope. Essentially, inside a function in JavaScript, I'm allowed to refer to variables that were defined outside the object or the function, including things that are ultimately getting defined like right now in the middle of this thing. So this is a way that I can write some JavaScript implementation that will let me call answer equals rect.area exactly like before, and it's going to do the same thing, except that I didn't use classes, I didn't use prototypes at all. So this is an example of just a different style of achieving the same data abstraction. So again, I could do the same thing, but make it be a triangle. So now instead of rect.area, it's try.area, and I base times height over 2 instead of width times height. Totally fine. And then I could use the fact that I'm allowed to do both of these to generalize this and make use of that abstraction and write a function that just says, hey, I'm just taking in a shape. I haven't even defined what a shape is. I didn't write down the word shape with a capital S anywhere in here. There's no interface. There's no class. There's no prototype. It's just, I just wrote a function. I wrote a function here, wrote a function here, and now I can call shape.area without knowing whether I'm going to be getting rectangle style width times height or triangle style base times height over 2. Both of those are going to work because I've abstracted over shape like this, and I did it without doing any OOP stuff. This is just another style you can use. I could even take that a step further and say, well, let's suppose I don't have this language feature of being able to refer to things outside the function. Maybe I'm writing C, for example, which doesn't have that feature. Well, I can make it a little bit less convenient. I can say I'll just take an explicit argument rather than referring to that one, and then say whatever that argument is, base times height. And now when I call it, I have to do shape.area passing in shape, which looks weird, but I can do it. Like, it works. I've achieved the same level of abstraction. By doing this, I still have the situation where I don't know anything about this shape other than it's got an area method. I can still call that and get either base times height over 2 or width times height, depending on whether I was given a rectangle or a triangle. All of that sort of fundamental abstraction stuff still works. It's really just a question of how convenient it was or wasn't. And this is a really important theme of what Paradigm does and doesn't get you. It's not so much about getting you something that you couldn't possibly do before. It's really about how well supported that is. So we can see, we have just seen lots of different ways to accept abstract data in a function or a method. We saw interfaces, traits, type classes, closures, non-closure functions, or even, if you were in C, you could go as far as function pointers. All of these are ways to achieve the idea of abstract types and passing abstract data between functions. They just have different ergonomics trade-offs and different stylistic trade-offs. So putting all that together, language paradigms are less about what styles of programming are possible. I mean, come on, they're all Turing-complete languages, right? That means anything's kind of equally possible. It's really just about how well those styles are supported, and also what styles the ecosystem embraces. Like, if you're doing that last style I showed where you're calling like shape.area, passing in shape, nobody else in the JavaScript ecosystem is doing it that way. That's kind of weird. Similarly, if you're trying to do that sort of like kind of overloading style in C, I'm not going to find too many people doing that unless it's, they're trying to do something very specific. So really, putting all this together, regardless of what features are present in the language, you can choose to do things in a different style that does or doesn't necessarily work well with those features. It's really kind of a question of how well supported are you going to be in that, how good are the ergonomics going to be of that style you're choosing to write in, and what's the ecosystem like around that. Okay, so the procedural style, to wrap all this up, I'm claiming is programming with less hierarchy, organizing code into just plain old data and procedures, and essentially just using modules for modularity instead of classes for encapsulation because they get you the same public-private thing. Okay. So, which brings us all to the shortest part of the talk. What changed? Putting all of this stuff together. So, walking around in Borders, I'm seeing all these great looking books about object-oriented programming. And now, I think back on that time, a couple decades later, and I just have this sense of having spent time with OO in industry and remembering all of these sort of promises of like, this is going to make things so much better. It's going to be like a really good answer to complexity. Programs are going to be a lot less brittle and stuff. And I just feel this sort of sense of disillusionment. Like, it was really exciting back at the time, but now kind of the shine is worn off. It doesn't feel like this exciting new thing that's going to solve a lot of problems. I mainly think about a term I've heard a lot when talking to people about this talk is people say like broken promises or not living up to the hype. I mean, you know, I think about a book like Clean Code. It's like, man, who doesn't want clean code? I don't want dirty code. I want clean code. And then you think, well, okay, you know, that's an exciting promise. But then you think about like, well, UML diagrams. I don't know. Was that an improvement over procedural programming? Yikes. That was okay. Maybe not. And then you think about like abstract singleton proxy factory bean. Like, was that like that's okay? I mean, is that a step forward? I don't know. So now that we've sort of gotten well past the sort of honeymoon phase of OO and the like excitement phase and kind of started to see like some of the excesses or things where things went too far, there's this reasonable and sort of natural reaction to kind of go back and revisit like, was this the right direction in the first place? And in a lot of cases, a lot of things about OO were likable, are nice. And you know, there's plenty of good reasons that OO languages continue to be widely used. It's not like everyone's like, throw it all out. But there's also plenty of reason to understand why people could say, yeah, you know what? I don't know. I don't know if it was worth it. I kind of want to take a step back and maybe revisit some of the earlier things, especially now that we've got a lot of modern conveniences like modules that are mainstream that weren't back in the days before OOP came out. A lot of people are looking at code like this and saying, yeah, I mean, I could put this in 3 classes named after nouns and have, you know, 9 total methods, or I could just have like 5 procedures named after verbs. I don't know, am I really missing out on a lot? Is this code really going to be brittle and hard to maintain? Because at a baseline, it seems like there's less code there. It's not doing as much. It seems easier to follow. I mean, I hear you, what you're saying in a lot of cases, you know, OOP thought leaders and things like that about, you know, oh, as your code base gets really, really big, you're going to want this stuff. But then a lot of us have had experience working in large OOP code bases and thinking, I still had those problems. I just had all this other stuff in addition to those problems. So, yeah. Disillusionment. It's a common thing that I hear when I talk to people about this topic. Especially when you consider like, well, if I want to do stuff like abstraction, polymorphism, you know, things like that, encapsulation, there's just lots of ways to do that. I can get encapsulation from modules. We've seen lots of different ways to accept abstract data. It's not like classes and subclasses and interfaces are the only way to do that. Composition over inheritance kind of makes sense, and if that's what I'm going to be doing anyway, do I need inheritance? It's just kind of this thing that I'm supposed to avoid, but in a lot of cases, the libraries I'm using are using it anyway, so I kind of can't avoid it. Is that a pro? Are we really still doing messaging, extreme late binding of all things, or is that kind of like, well, you know, it's cool that was the vision, but that's just not what people are doing in the OOP world anyway. So putting all these things together, it starts to feel not like the end of the era is now, but maybe like we're kind of heading towards the end of an era. Maybe we're past the peak of OOP, and there's a reason that procedural is coming back, which is just that people are saying, yeah, I don't know. I think maybe things are a little bit better and a little bit simpler in the old days. And I think that is sort of a trend, and it's why we're starting to see new programming languages saying explicitly, yeah, you know what, we're just not going to do that. We're going to explicitly be procedural. We're not going to go in the C++ direction. We're going to say, you know, start with C and then try to fix some of the problems. And you can see analogies with that in other languages, not just low-level system languages. Granted, a lot of that is, you know, going in a functional programming direction, but it's the same kind of idea. It's saying like, let's do less hierarchy. Let's just have plain old functions and data, and we think that's just going to make our lives better. It's understandable. So what changed? Well, essentially, to put all of this stuff together, many of object-oriented programming's selling points are today just commonplace in other paradigms, and many of its other signature features, like inheritance, message passing, late binding, have fallen out of favor in favor of things like static type checking, just not doing messaging, and doing composition over inheritance. So putting all this together, it's sort of like, well, if you're going to be in the imperative world, procedural programming today offers a lot of common selling points without the disfavored stuff. So if you're sort of on board with this idea of, hey, what if I just want to let data just be data, let actions just be actions, so maybe you can understand why we're starting to see return of procedural programming. Thanks very much.
Hi, awesome talk. Thanks so much. Just a really quick question. There's a kind of cynical view that like more class-based programming languages kind of force you into one style. I'm thinking Java in particular. Whereas you have much more freedom, which means people can kind of do whatever they want, and you don't have like a unified style guide unless you enforce those patterns. Could you maybe speak to that a little bit with this kind of like move to a new paradigm?
Yeah, so the question is like, there's somewhat of a cynical view that you could look at and you could say like, you know, Java especially, you gave the example of sort of forces you into this like hierarchical style and like, you know, noun-based programming and so forth, whereas other paradigms like procedural and functional give you more freedom to explore. I think I don't know if that's necessarily cynical. I think you could very easily look at that as a good thing or a bad thing. Like in some sense, like I said, a lot of the things like when I've talked to people about this topic that come up are people saying, you know what I really liked about OOP is it was really clear how to organize my program, is like around classes. And you do lose that if you say we're just going to have modules that don't really sort of give you that really strong push to being like I'm going to co-locate my my data with the operations that work on it. So I would say it's accurate in the sense that like certainly Java does very strongly push you in that direction. I remember thinking it's really cool in Java, like when I first used it, that like everything is an object except for primitives. That actually really bothered me that like int was like not an object, and I heard it was in Ruby and I was like cool. But at the same time it was also weird that like, you know, before you had like public static void main, you had to put that in a class, and I was like, huh? It's like that's where the program starts. Why am I making a noun out of this? It just felt weird, and it still feels weird. So I'd say there's pros and cons to that. I don't know that it's like, you know, all upside or all downside there. At least that's my perspective. Yeah. It's still weird to me that still water comes in a can because I feel like I'm like, oh yeah, time to hit the sauce after that talk.
So speaking just for myself, OOP was all about tying together the data with the methods that work on the data. And I think that idea has persisted. So if you look at Rust, you have a struct and then you have an impl. If you have Go, you can define functions with a receiver that just looking at your code looks like you're working with objects. Comments?
Totally, yeah. So you know, the idea of like coupling data and, you know, the operations that work on it, especially like into a namespace, especially with like public and private, I think that like has turned out to be kind of a good idea. The interesting thing though is the question, at least to me, the interesting thing is the question of do you have to do it that way, or do you make that like a convention that's sort of opt-in, and maybe you can also have modules that don't do that, or maybe operate on multiple data types at once. And then B, the question of, okay, let's say that you have organized your code that way. What does that imply? Like you gave the example like Rust traits and like impls. Like even if you're not using traits, you can still like have an impl just to get the sort of method-looking syntax, which I personally do in Rust code all the time. But then the question becomes, well, what are the implications of doing that? And in Rust's case, if you're not using a trait, the implications are really just kind of syntax. It just looks kind of methody. And also there's like some type conveniences. You don't have to like repeat the type in as many places. You can just say self, and that just is whatever the type of the original thing was. But what you're not getting is you're not opting into like inheritance. You're not saying, oh, well now people can subclass this, or you know, I might be subclassing someone else and overriding things. That whole part of it is sort of gone, and that does seem to be something that's a pretty bright line between the like object-oriented languages and the procedural and functional languages, is whether or not sort of coupling data to the functions that operate on it involves subclassing and overriding like that. But I think the fundamental idea is like, yeah, it's a good way to organize things. I think that's uncontroversial at this point. And also credit to OOP for popularizing that, I think. Other questions? Okay, thanks very much.